Alright, so welcome back to everyone. A very warm welcome to all of you, my dearest students. A very warm welcome to all of you. So, guys, here I am again with this units and measurement chapter, and in this session, we are going to talk about the vernier calipers. Okay, in this session, we will be speaking of the vernier calipers. So, vernier calipers, I hope all of you must have heard that it is used in measurement. It is used in measurement of this, used in measurement of our length, etc. Right? Okay. Okay, so guys, I hope all the live students can once confirm me that you can see me and hear me properly, right? The live students, okay. Okay, so let's move ahead. So guys, in the last session, we have concluded about the error analysis. Okay, error analysis, and see, we have spoken that how it is very much evident that in every measurement there will be some error, no matter how hard you try. Okay, no matter how hard you try, there will be some error. There will be some error in the measurement. Okay, you cannot avoid that, right? You cannot avoid that. Okay, now in this session what we are going to talk about, so we are going to talk about the vernier caliper, or sometimes known as the vernier scale. Okay, so this is a device used for measurement of length, height, width, diameter, internal diameter, and so many things. Okay, okay, so we'll be talking about it, why we needed the vernier caliper in the first place. We'll be talking about it, and how can we do the problems, how can we approach the problems of vernier caliper. We shall be talking about that as well in this particular session. Okay, okay, so basically, let me introduce myself to you guys. So I hope you guys are knowing me now. I am Dr. Shankar Sir, your physics educator, and these are my credentials. And before I begin with the session, I would request you to subscribe the channel, like the video. Your only channel needs success simplified. Okay, so let's move forward. Let's move forward. So, guys, we are going to talk about the vernier caliper. Okay, vernier caliper. Okay, now please understand this. Why do we require this vernier caliper? So obviously, sir, this vernier caliper is used for the measurement of length, diameter, all these things. But sir, these can also be measured from the meter scale. So why not we are using the meter scale, and what is the need of? What is the need of using the vernier caliper? Okay, okay. So sir, please understand. Please understand this. So commonly, what is the device we use for measuring of length, height, width, etc. Okay. So, sir, we normally use the meter scale, the normal scale that we carry with us, or you may say that the scale, or like the inch tape that we usually, you will see that lot of technical workers carry with themselves. Okay. Okay, so sir, that meter scale, why can't we use for the length? So we definitely can use that for measuring the length. There is nothing like that. But the thing is, now please understand this. So all of you must have seen the meter scale, right? Sir, yes, sir, we have seen the meter scale. Now in the meter scale, you would have observed some divisions, right? Like this. Some division you might have observed. Okay, some divisions you might have observed somewhat like this. So this is 0, 1, okay, 2, and so on, and so on. Now please understand this. Now please understand this. Let us suppose that we have an object, okay, somewhat like this, and we want to measure the length of this object, okay, like the length be L. Now you tried measuring this through the meter scale, okay, through the meter scale. So you can bring it to the meter scale, or you can bring the meter scale to this object, either way. Okay, so now when you measured this length, what happened? It goes somewhat like this. Please observe, it went somewhat like this. Okay, just try to observe. Just try to observe something. Yeah, somewhat like this. Okay, you tried measuring through the scale and it went somewhat like this. Now, if I want to read this, I can say, now please understand this, I can say that, sir, this is 1 and then this is 1, so 1.1 centimeter. Okay, okay. Now, is it the true or is it having some error? So, sir, in this, the diagram you have made, I can see, I can see that, sir, it is not exactly 1.1. It is not exactly, it is not exactly 1.1, right? Can you feel so? That this is not exactly 1.1. Sir, it is slightly more than 1.1. This is what we can observe from this very diagram that you have made here. Okay. Now, when I say it is more than 1.1, so you can observe that it can be anywhere between 1.1 and 1.2. But it is not exactly 1.1, it is not exactly 1.2. It may be 1.12, it may be 1.11, it may be 1.14, it may be 1.16, it may be 1.17, or it can be anything between 1.1 to 1.2, but it is not exactly 1.2. Okay, or neither it is exactly 1.1. Right. Now, do you feel that there is some error in the measurement, okay, from this meter scale? Do you feel so? I'm trying to make it very, very clear to you so that you understand this whole concept of using the vernier caliper. Now, what do we realize from here? So I'm talking about this meter scale. Okay, I am talking about this meter scale. So from the meter scale, observe that you can correctly, or you can, so what we can say, so from meter scale, measurement can be made, measurement can be made, measurement can be made with accuracy up to 1 decimal place. Measurement can be made with accuracy with accuracy of 1 decimal place. Okay, because you cannot accurately tell, whether it is 1.12, whether it is 1.13, whether it is 1.14, whether it is 1.15, or whether it is what. Okay, so from 1.1 to 1.2 there can be many possibilities. Okay, there can be many possibilities. So see, you can be sure that it is more than 1.1, you can be sure it is less than 1.2, but you cannot be assured of this thing, that whether it is 1.12, 14, 15, 16, or what, or whatever. Okay, so you can't be sure of that, right? Are you getting my point? Yes, sir. Okay. Now, what we can say, so from meter scale, the general scale that we are using, the measurement can be made with accuracy of 1 decimal place. So, for example, if let's suppose if a rod or something like that, having, if a rod having length of, let's suppose, 2.28 centimeters, that is the true length. Let's suppose the rod has this true length of 2.28 centimeter. Now, can you measure this accurately with the help of a meter scale? No, sir, we cannot, because we cannot measure, we cannot measure we cannot get a measurement of accuracy up to 2 decimal places from the meter scale. Okay. Now, if you want to improve the accuracy, you must look for another instrument, another device for the measurement, and that very device is the vernier caliper. Okay, that very device is the vernier caliper. Now, here let's try to understand, before I move to the vernier caliper, let's try to understand one more thing, which is least count. Okay, so I have explained this least count to you in the previous session of errors also. So what is the least count of an instrument, of any instrument, be it instrument of measuring length, be it instrument of measuring time, be it instrument of measuring anything else? Okay, so what is the least count? So the least count is, what is the least count? So the least count is, the minimum. The least count is the minimum measurement. Least count is the minimum measurement that can be made, that can be made from any instrument, okay. Okay, like if I ask you, like what is the least count of this meter scale? What is the least count of this meter scale? What is going to be the least count of this meter scale? Can you tell me that? What is going to be the least count of this meter scale? Can you tell me that? So, sir, now here in each of the division is equal to 1 mm. So if I say in centimeter, it's centimeter. So each division is 1 mm, right? Each division is 1 mm. So when each division is 1 mm, so what does that mean? When each division is 1 mm, it means that the minimum measurement that you can do from a meter scale is of 1 mm. You cannot measure anything below 1 mm. So if I talk about the least count of the meter scale, the least count of the meter scale, it is going to be 1 mm, and I can obviously write 1 mm is equal to 0.1 centimeter. So that is the reason why. Now see, please try to relate. So this is the reason why, because least count is 0.1 centimeter, we can measure length up to the accuracy of 1 decimal place. Okay, because each division reads 0.1 centimeter. Each division reads 0.1 centimeter. Okay, okay. Now, what is the vernier caliper? Let's come to the vernier caliper. So, what are the limitations of meter scale? So, meter scale can give accuracy up to 1 decimal place. Now, if you want to have accuracy for 2 decimal place, so as I was saying, if a rod having length of 2.28 centimeter, so we cannot measure it. We can't measure this. We can't measure it accurately. We can't measure it accurately using meter scale. Okay, okay, because from the meter scale, obviously either you are going to get 2.2 or 2.3 or somewhere between 2.2 and 2.3. So you can end up guessing, okay, it is very near to 2.3, so it must be, it would be zero point 0.8, like that. Okay, like that. Okay, are you getting my point? Okay, so if a rod having length 2.28 centimeter, we cannot measure it accurately using the meter scale. But if we want to measure something with the accuracy of the second decimal place, we can choose a vernier caliper. Now please understand this. So we have, let's suppose we are having a vernier caliper. Now please understand this. Now this vernier caliper is what? Now this vernier caliper is what? So this vernier caliper is a device which is having least count of 0.01 centimeter. Least count of 0.01 centimeter. Generally, okay, generally. So see, it is not, no, don't take me wrong. So in the question, so in practical also, vernier caliper can have the least count other than this value. But generally, when I speak, so I have a vernier caliper with me today here. This is what we see like a vernier caliper. This is a vernier caliper. Okay, this is a vernier caliper. So this vernier caliper that is available in the market, or you may be seeing in your laboratories. Okay, see, look like this. Okay, it somewhat look like this. We'll talk about it. We'll talk about it. So this vernier caliper that you usually see in your laboratories, in industries, in market, when you go to buy in the market, I don't think that you ever have gone to buy a Vernier caliper, because the our work like can be done by the meter scale in general life, no. But when we are learning the measurement, and also I want to tell you, so don't be, I have cleared this in the previous video also. I have dedicatedly made a video upon the syllabus changes. So Vernier caliper is there in your syllabus. Don't get confused, don't get trapped. Okay, so Vernier caliper is there in your syllabus, and it is written in unit 20, that is the last unit of experimentation. If you see the first 2 points, both Vernier caliper and screw gauges are given there, so you have to study it. Okay, okay. Now please understand this. So generally a Vernier caliper has a least count of 0.01 centimeter. Okay, 0.01 centimeter. But remember, you see a problem of Vernier caliper, don't presume that it has a least count of 0.01 centimeter. I'll give you the ways to calculate the I'll give you the ways to calculate the least count of the Vernier caliper. Okay, we'll solve the questions, and from the questions we'll come to know that what is the least count of the Vernier caliper, how to calculate it, and we are going to see the process. But see what happens, why I am giving so much thrust on this particular thing, or this particular about this particular thing, because you see, I have seen students, when they see a question of Vernier caliper, they by default use this least count as 0.01 centimeter. You don't do that. Okay, you please don't do that. You calculate the least count of Vernier caliper, and how to calculate it, we are going to talk about it. But in general, if I talk, so Vernier caliper is something which gives the least count of 0.01 centimeter. Okay, so what does that mean? From a general Vernier caliper, what can we do? So from a general Vernier caliper, we can measure, so least count 0.01, so that means we can measure accurately up to 2 decimal places. We can measure accurately up to 2 decimal places. Okay, okay. So if we can measure accurately, up to 2 decimal places. Okay, so whatever is the least count tells you that till what decimal places you can make the accurate measurement generally. Like for example, afterwards we are going to talk about a screw gauge. Now generally, see, it can have any least count according to its arrangement, but generally the least count of a screw gauge is 0.001 centimeter. Now live students, please tell me, till what decimal places the screw gauge can make accurate measurement? What do you think? Till what decimal places the screw gauge can make accurate measurement? Can you tell me? Please think. So obviously, sir, see, you can correlate, no? So for meter scale, when the least count was 0.1, we could measure up to 1 decimal place accurately. When the least count was 0.01, as in the case of your uh, Vernier caliper, you can measure up to 2 decimal places. Right? Now, similarly, for screw gauge, when the least count is 0.001 centimeter, that means in centimeter when you are measuring. So when you are measuring up to 3 decimal places, so when the screw gauge is having least count of 0.001, that means you can measure accurately up to 3 decimal places. Okay. Okay, I hope it is fine to everyone. So we understood, sir, why why we need vernier caliper and why we need screw gauge for that matter, because the screw gauge will give you more accuracy. Okay, so in our course we have meter scale, vernier caliper, and screw gauge. So out of these, the screw gauge is most accurate, followed by vernier caliper, followed by meter scale. Okay, followed by the meter scale. I hope it is fine to everyone. Okay, I hope it is fine to everyone. Now please understand this. Now please understand this. So we have the screw gauge, we have the vernier caliper, we have learned about it. Now please understand this, that what are the uses of the vernier caliper? Now if I write the uses, so what are the uses? So uses of vernier caliper, so it can be used to measure, it can be used to measure. Okay, so why it is important? So it is important to know now that what is the use of the vernier caliper. So it can be used to measure length, width, height of regular shape objects. Okay, regular shape objects. Okay, okay. Moreover, it can be used to measure dia, radius, okay, etc. Okay, it can also be used to measure depth of beaker, tube. That means it can be used to measure the depth of hollow small things. Okay, regular shape objects. So obviously it is used for small objects. Okay, so see, I'll have practically I am holding a vernier caliper here. So you see the size of it, very small, no? Okay, very small. Okay, so it is not that large that it can be used for measurement of larger objects. So in laboratories also, when we want to measure small objects, normally then we use the vernier caliper and screw gauge, because see, more technicality, more calculation is required. In meter scale, you right away when you see the length, you try measuring from the meter scale. Right away, anyone can tell that what is the length from a meter scale. Okay, but for measurement through vernier caliper, screw gauge, some mathematics is involved. So, like I want to say, like not everyone can make measurements from these. Okay, if there is a layman, or there is a non-technical person, not a science student, if you ask him to measure through vernier caliper, that could be a difficult task for him, because he doesn't know how to make calculation, how to see from the vernier caliper, right? Okay, okay, I hope it is fine to everyone. And it can be also used to measure internal dia. It can also be used to measure internal dia of any object, internal dia of some hollow object or hollow cylinder, something. Okay, okay. So see, basically vernier caliper is something which can be widely used. It has wide use case, right? It has quite a wide use case. Okay, okay. Now how the vernier caliper look like? Now I'll show you one image. Okay, I'll show you one image and you can relate it with the practical vernier caliper I am holding for you. Okay, so let us see. So we have somewhat like this. Okay, I hope you can see this image. So we have something here. Okay, okay. So this is your vernier caliper. I'll just make it a little slightly above. Yeah. Okay, let me have it. Yeah, now it is fine. Now it is fine. Okay, so we have a Vernier caliper here. We have a Vernier caliper here. Now I hope you can see this Vernier caliper clearly, right? Can you see this Vernier caliper clearly? Just have a look at it for one moment. Just have a look at it. Okay, just have a look at it. Okay, and now try to compare this. Now try to see this with the original Vernier caliper I am having with me today. Okay, okay. Now looking quite same, no? Looking quite same. So you can move it like this. Okay, you can have it. Yeah. So you can move it like this. Okay, like this. Now you see exactly what we are having. Everything is quite similar now, like the same. Okay, okay. Now see each of this. So we must know that what are the parts of it. So please understand this. Please understand this. What they are called upon, and then we'll do some measurement. We'll do some measurement. Don't worry. So see, please understand. First, let me explain you what are the parts. So basically, these are the jaws which we normally use. Jaws normally used for measurement of outer dimensions. Okay, this is what we use for the measurement of outer dimensions. So if we want to measure the outer dimensions of something, we may use these two jaws. So how do we use? So just see, I'll explain you everything. So let's suppose I have a pen and I want to measure. So this is the topic which is very, very challenging to teach also. Okay, why so, sir? Because see, this is something very practical. Okay, like this is our experimental part, and I am teaching you online, right? So you have to bear with me. Okay, you may feel that this is a little boring. Okay, but what to do? It is in your syllabus, and unless see, it will take some time. But see, in anything which is experimental, okay, so can you teach someone to drive a motorcycle just like this? Okay, it is very difficult task, right? Because see, only the person see when unless you practically use it, you won't have the best clarity. But still, I'll try my best to make you understand this, but it will take some time. Today's lecture is going to take some time. So see, I want to measure the diameter of this pen, so I can hold this in between these two jaws like this. Okay, like this. I have had. Okay, okay, and then how we are going to, what is the reading? All this I am going to answer you. Don't worry. Okay, we'll go step by step. Okay, okay. So these are the jaws which are normally used for measurement of outer dimension. Now these are what? So these are the jaws. These for internal dia measurement. Okay, these jaws are we using for internal dia measurement. Okay, we are using it for internal dia measurement. Okay, and this is the stem. Now please understand this. This is the stem. This is the stem for depth measurement. This is the stem for the measurement of depth. Stem for depth measurement. So basically, when we are measuring something, we can use any of these jaws according to the geometry, shape, and physics of that particular thing that you are measuring. Okay, okay. Now, please understand this. I'll just make it again. Okay, just one moment. Now here we are interested basically in two things. Okay, because see, ultimately we are here to qualify the NEET examination, to get good marks in physics in the NEET examination. So let me come to the point straight away. So see, there are two things here which is very important. So here you can see two scales. Here you can see two scales. This is what we call as the main scale. Okay, this is what we call as the main scale, and this is what we call as the Vernier scale. Okay, this is what we call as the Vernier scale. Okay, so we have a main scale, we have a Vernier scale. Okay, so there are two main things here with the help of which we can do the measurement, we can take the reading. So we have the main scale, we have the Vernier scale. Now, if you see a Vernier caliper, so here It is very difficult for you to see because these are obviously very small. You cannot see the dimensions here, the one I am having. So here you can observe, but at least that's the what is the vernier scale, what is the main scale. So see, this is this is in the bottom. You can see this is the vernier scale, and this is the in the top. We have the main scale. Okay. Now please observe. Now please observe this. So please understand this. Okay. So there are divisions. So this main scale is somewhat. So see, if you observe here, if you zoom in and you observe, so this is centimeter. Okay, I'll just show you. Just see, just observe. Okay, just observe. So this is going not to be, yeah, yeah. So here, if you observe in this scale, let's observe. So here it is written in centimeter. Here it is written in centimeter. So it is the main scale is kind of the meter scale that we usually see. Main scale is kind of the meter scale that we usually see. Okay, and it is in centimeter. It is in the centimeter, right? It is in the centimeter. So from here to here, this is how much? This is 1 centimeter, right? Each of the division is of zero point 0.1 centimeter. Okay, let's take some observation, right? From this point to this point, obviously it is 1 centimeter, and each of the division B is zero point 0.1 centimeter. Okay, zero point 0.1 centimeter. Okay, now please understand this. Please understand the situation. Now please observe. So let's suppose that I have measured something. I have measured something. Like let's suppose I am measuring the dia of my pen. Okay, the dia of this pen. So I have held this pen in this. Okay, like this. I am holding this pen into this, and obviously I'll make sure that this is tighten enough. And there is, you see, this is the lock. If you rotate this, it will get locked inside this. Okay, so you can hold this pen here, and then you can lock. Okay, okay. Now you see. Now if you see, if you observe it clearly, now there is some position on the of the vernier scale over the main scale. Okay, there is some position of vernier scale over the main scale. Now using this, we are going to see the reading. So I'll come to this also. But first, let's talk about the division. So as I have shown you here, as I have shown you here, in the main scale, it is basically like the meter scale. Okay, it is basically like the meter scale. So if I make the main scale here, okay, this is your main scale, and somewhere on this main scale there is a vernier scale. Okay, related to it. So let's suppose this is the main scale and this is the vernier scale. This is the vernier scale. Now please observe this. Now please observe this. I want you to observe this thing. So now if you see, so I'll just try to see up. Now, if you observe them, if you observe it, please, if you observe the divisions, okay. So let's suppose that the main scale has divisions. Okay, I'm trying to make the divisions here. 1, 2, 3, 4, 5. Okay, so I'll just stop till this point. So this is 0, this is 1. Okay, that means till here the distance is 1 centimeter, because each of the division is, okay, each division, please listen to me carefully, please listen to each and every word. See, many of you might be thinking that it is going very slow, but see, this is something very, very important. And unless if you feel slow right now, you will not be able to do the question. Okay, you will get confused. Okay, please understand. So don't do like that. Okay, now we have some divisions on the main scale. Okay, and in general, a vernier scale division is equal to one main scale division. Okay, one main scale division in general vernier caliper, not always. It is equal to zero point 0.1 centimeter. That means the distance between these two divisions is 0.1 centimeter, because it is generally like the meter scale that we have. Okay. Now let's talk about a vernier caliper. Now, if you observe the vernier caliper, what you are going to observe, I'll just tell you. I'll just tell you. So there will be some divisions in the Vernier caliper as well. In the Vernier caliper as well. And if I see this Vernier scale with me, centimeter is written here on the main scale. Centimeter is written here on the main scale, but nothing is written. Nothing is written on the Vernier scale. Now, one main scale division in this case of a general vernier caliper is 0.1 centimeter. Now, the question is one vernier scale division. One vernier scale division. Okay, so VSD is what? I'll just write it for once, and afterwards I'll use MSD and VSD. So one vernier scale division, it is equal to what? One vernier scale division, it is equal to what? So sorry, it is equal to what? We don't know, because it is not mentioned whether it is in centimeter, it is in mm, or it is in what unit. Okay, so we don't know that what is the vernier scale division. Okay, okay, what is the vernier scale division? Okay, then sir, how we shall proceed? How we shall proceed? Now, one thing is very clear. If you observe the vernier caliper, one thing is very clear. One thing is very clear, that each division, okay, please understand this. This is when you see a practical vernier caliper as I am holding in my hand. So from here, this is very clear. It is very observant from here that one vernier scale division. Okay, please observe this. One vernier scale division is less than one main scale division. Again, this is a general thing. Okay, there could be, they can make a question where one vernier scale division is more than the main scale division, but to the NEET standard that wouldn't be required, so I'll not be covering that. Okay, so in general, in 99.99999% time, one vernier scale division is less than one main scale division. Okay, okay, and if you observe, now if you observe, so see what happens, so let's suppose, so now sir, I want to know, first of all, see, we need to know that what does vernier scale division signify. As the main scale division is equal to zero point 0.1 centimeter, what does one vernier scale division signify? Okay, this is something we must know, unless we cannot make the measurement. Okay, okay, now please observe this. So one vernier scale division is obviously less than one main scale division. Okay, because the main scale is like meter scale. So if you use main scale only, see, if you use a little bit of logic also in this way, if you use the main scale only, you can again measure with the accuracy up to one decimal place. Okay, but when you want to measure more accurately, when you want to measure up to two decimal places, obviously you must use the vernier scale, and then the division of the vernier scale has to be less than the main scale division, because otherwise it cannot measure less than zero point 0.1 centimeter. Okay, see, if you are, if see the see, please try to think. So vernier scale division has to be, if you have never seen the vernier caliper and you have no intention to see it in the future as well, you have no intention to go to your laboratory as well, just think, just use your common sense. Sir, what is the what we need to do? So when the main scale division, when the main scale division is equal to zero point 0.1 centimeter, the vernier scale division has to be less than 0 0.1 centimeter. Then only you will be able to know measure less than 0 0.1 centimeter. Okay, okay. Now please observe this. Now please observe this. Now again, some common sense thing. Okay, okay. So one vernier scale division is less than one main scale division. Okay, okay. So that means what? That means what? How you are going to interpret that? Okay, how you are going to interpret that? So you are going to interpret that in nine. So please understand it. So since vernier scale division is less than the main scale division, okay. So let's suppose this is the main scale division. This is the main scale division, and this is like this. This is like this. So this is your main scale division. Okay. Okay. Now till this, let's suppose this is 10 divisions. Okay. This is or I'll do like this. Okay. So how many divisions are there, sir? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 9 divisions. Up to this point, 9 divisions are there. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 divisions are there. Now, now please observe, this is one very key point. Many students getting confused here. So now if you see Vernier scale, if you see the Vernier scale, let's suppose this is the Vernier scale. Now till this 9 divisions, how many divisions of Vernier scale would be? So obviously, since Vernier scale division is less than the main scale division, there will be no more number. So generally, in general Vernier caliper, it is 10 division. Okay, please think. See, Vernier scale division is shorter than the main scale division. Okay, okay. So if I see that 9 division of the main scale, till 9 divisions of the main scale, we have 10 divisions of Vernier scale. Are you getting my point? Please understand this. Please understand this. Since each of the Vernier scale division is less than the main scale division, so in 9 main scale divisions, there will be 10 Vernier scale divisions. I'm just taking a code. Okay. Okay. This is, I'm talking about the general Vernier caliper. Just trying to give you the context or concept. Okay. So basically, in lesser divisions of main scale, there will be more divisions of the Vernier scale. Did you get my point or not? Did you get this point or not? Did you get this point or not? Okay. In 9 divisions of the main scale, there will be more divisions of Vernier scale, because see, Vernier scale division is less than the main scale division. Okay. Okay. So each of the division, think in this way, each of the division is each of the division of Vernier scale is less than the main scale division. Okay. So when you take 9 main scale division, there may be 10 Vernier scale divisions which are covering that much distance. Okay. Okay. So please understand this. Please understand this. So see, in general Vernier caliper, so if I can say if Vernier scale division is less than the main scale division, okay, main scale division, and if please understand this, if n Vernier, then, or I can write, if a Vernier scale division is less than the main scale division, then n Vernier scale division, then n Vernier scale division is equal to m main scale division. Okay, do you understand it? The same way. Okay, and obviously in this case n will be greater than m, because see, obviously, see, I'll how I'll explain to you. See, I have uh let's say I have some chocolates. Okay, I have some chocolates of two companies, say company A, company B. Okay, company A, company B, and the size of the chocolate of company A is less than the size of the chocolate of company B. Now, if I place them one after the other, since the size of company A chocolate is less than the size of company B chocolate, so when you put three chocolates of company B, you will be if you want to match that length from company A chocolate, obviously the number of company A chocolates used would be more. Don't you feel so? Okay, don't you feel so? Let's suppose we have company A chocolate, company A chocolate. Okay, and this is the company A chocolate. Okay, this is the size of company A chocolate. Let's suppose this is of 10 centimeter. Okay, this is of 10 centimeter, and company B chocolate. Company B chocolate. Okay. Company B chocolate. We have the size of, let's suppose, anything you can take. Let's suppose 9 centimeter. Each of it is 9 centimeter. Okay. Okay. Now please understand this. Now please think. Now please think. I think after this you will be able to understand this concept. Now if I keep 10 of company A chocolate. Okay. Sorry, 9 of company A chocolate. So this is company A chocolate. Okay. And you put it as 9. Okay. You put it as 9. Okay. So 9 company A chocolates you have placed. So when you have placed 9 company A chocolates, so this is number, how many numbers? Number is 9. Okay. So you are placing 9 company A chocolate one after other, and you want to match this length from company B chocolate. Okay, so how many company B chocolate you need to place? You need to place 10 company B chocolates, right? I'm just randomly making this. Okay, so this has to be 10 number. Okay, because each of the company B chocolate, so this has to be 10 numbers now, because each of the company B chocolate is 9 centimeter. Okay, each of the company B chocolate is 9 centimeter. Okay, okay, so what happens? What happens here? When you are taking 9 company A chocolates, that is equal to the 10 company B chocolates. Similarly, now please write. I think after this it would be clear. So the same way, since the Vernier scale division is less than the main scale division by length, so there will be more Vernier scale divisions in any given number of main scale divisions. Okay, okay. So if vertical Vernier scale division is less than the main scale division, then we can say that n Vernier scale division is equal to m main scale division. Okay, so in every question this is going to be changed. This is going to be changed. So that means can we write, so that means very important concept, that one Vernier scale division is equal to m by n of the main scale division. So main scale division, the main scale is already calibrated. The main scale is already calibrated in the centimeters. So you know the each division of the main scale gives you 0.1 centimeter, but you don't know that what is the Vernier scale division is equal to. What is the Vernier scale division is equal to? So now, if you have this information that how many Vernier scale divisions are equal to how many main scale divisions, okay? And remember, this is very confusing. No, which is greater? N is greater. So Vernier scale division is less than main scale division. Then N is going to greater than M. If reverse, see, not in NEET, I don't think that they are going to ask you this complicated question in NEET as far as this measurement is concerned. But still, if you know the concept, you will be able to do it. What happens if main scale division is greater than the Vernier scale division? So what is going to happen? Sir, M will become greater than N, right? M will become greater than N. Okay. So now here, one Vernier scale division is equal to m by n main scale division. And since n is greater than m, okay, n is greater than m, this is going to be less than 1. This is going to be less than 1. Now the same thing again came to you. Same thing again came to you. Okay. So VSD is equal to m by n MSD, and this is less than 1. So that means Vernier scale division is less than the main scale division. This is where we started off. Okay. Now, very important thing. Now, very important thing. Now, very important thing. So, what is the least count? What is the least count? Please observe. Very important concept. What is the least count? Now, please use your common sense. See, these kind of topics are most difficult to teach. Okay, most difficult topics to teach, I would say. Why, sir, this is most difficult? You are saying to teach, not to understand, to teach. Because see, this is something very practical. Now, that is why I have brought the Vernier caliper from my university laboratory. Okay, like it is not going to help you a lot because you cannot see the divisions here, but just to have a practical, kick. Okay, So least count is what? What is the least count? You tell me, the live student, just tell me. And the recording student, the students who are watching the recorded session of this video, you also pause the video and think for a moment that what is the least count of any instrument? What is the least count of any instrument? The least count of any instrument, is least count of any instrument is the minimum measurement. It is the minimum measurement that can be done from that particular instrument. Okay. Okay. So this is the minimum measurement that can be done from a particular instrument. So what is, so let's suppose this is, so I am magnifying one division. Let's suppose this is one division. I just magnified it. So let's suppose this is A. A is the main scale division. So this is 0.1, no? This is 0.1. Sir, please remember, I said generally. Please remember this word that I am using here. Generally, the main scale division is 0.1 centimeter, but it is not necessary. It can be anything else. Now we are moving towards the main content. Okay, so A can be anything. Let's suppose A is the main scale division. Okay, or one division of main scale. MSD is main scale division. Okay, and let's suppose that beneath it we have a Vernier scale division. Let's suppose B is the Vernier scale division. B is the Vernier scale division. And now you have come to know that what is the Vernier scale division. Okay, if you have the main scale division, now from the concept we just learned that N Vernier scale divisions are equal to M main scale divisions and N is greater than M. So one Vernier scale division is equal to M by N main scale division. So you now know, because I am assuming that you know the main scale division. So assuming that now you know the Vernier scale division. Now, what is the minimum measurement you can do out of this Vernier caliper? This is the, I could skip it. I can give you the least count formula like many educators are doing. So they just give you the formula of least count, and you are also happy. Okay, sir, we have got this formula, main scale division minus Vernier scale division, but like with time you forget it. If the question is twisted, the language is twisted, you are unable to do it. I don't want that to happen to you. That is why I am taking this to this much detail. And also this time, this Vernier caliper is given and screw gauge is given some more attention by the NEET people. They have separately mentioned it in another unit. Okay, so we have to be taking this factor of safety. That we have to understand this very well conceptually so that we can solve some tricky questions as well as when required. Okay. Okay. Now, sir, please answer this. So, what is the minimum possible measurement that one can do from a Vernier caliper? Sir, this would be equal to the main scale division. No. Sir, it is equal to the Vernier scale division. So I'll tell you. Let's see be the very interesting thing. Let's see be the difference of main scale division and Vernier scale division. Now, please understand this. Please think, if any object is there, can't you measure this distance? Can you? So you know the main scale division, you know the Vernier scale division. Can't you find the difference in the main scale division and Vernier scale division? Yes, sir, definitely we can find. So you can find this distance also. So this is the least count. Now, neither the main scale division is the least count, neither the Vernier scale. See, neither the main scale division is your least count, nor the Vernier scale division is your least count, but the difference of these two is your least count. Okay, this is the least count of Vernier caliper. This is the least count of Vernier caliper. So what is the least count? So this C is equal to least count of Vernier caliper is equal to main scale division minus Vernier scale division. So I can write it here, main scale division minus Vernier scale division. So Vernier scale division is M by N of Vernier scale division, main scale division, sorry. m by n of main scale division. So that means the least count is going to be, sir, main scale division and in the bracket 1 minus m by n. So this is going to be the least count of the Vernier caliper. This is going to be the least count of Vernier caliper, where remember n is greater than m. Don't you forget that n is greater than m. Remember that. Okay, this will help you in future. Sometimes people, memorize this also. Okay, so one least count is equal to MSD minus VSD, and one VSD is equal to m by n of MSD. So the least count is MSD into 1 minus m by n. I hope it is clear to everyone. So this is how we can get. This is how we can get the least count of a Vernier caliper. Okay. Okay. Now please understand this. Let's move to the ordinary Vernier caliper. So now I hope this concept is clear to everyone. Now what happens in the ordinary Vernier caliper, the Vernier caliper that I am holding right now, or the Vernier caliper that is available in the market, industry, laboratories. So in the ordinary Vernier caliper, what happens? First of all, the main scale division, as I said, it is quite like the main scale, or sorry, meter scale. So one main scale division is equal to zero point 0.1 of centimeter. It is equal to 0.1 of centimeter. Okay, okay, and this is one information. One main scale division is equal to 0.1 of centimeter, and one VSD. Okay, that is one Vernier scale division. We know it is m by n of main scale division. Okay, so in an ordinary Vernier caliper, what happens? In an ordinary Vernier caliper, what happens? That 10 Vernier scale divisions are equal to 9 main scale divisions. Okay, in general, in normal Vernier caliper, this is the case where 10 Vernier scale divisions are equal to 9 main scale divisions. Okay, okay. This is made like this. This is manufactured like this, that 10 Vernier scale divisions are going to be equal to 9 main scale divisions. Okay, 9 main scale divisions. Okay, okay. So from here, what we can write, sir, one Vernier scale division is equal to 9 by 10 main scale division. So what is going to be the least count there? So the least count is the main scale division into 1 minus m by n, or you can do by the basics, main scale division minus Vernier scale division. So let's do by that. Main scale division minus Vernier scale division. So we can write main scale division minus m by n of main scale division. So we can write that the least count is main scale division and in the bracket 1 minus m by n. Okay, so what is the main scale division in this case equal to? Sir, it is equal to 0.1. It is equal to 0.1, and how many? So sir, 9 main scale divisions are equal to 10 Vernier scale divisions. So we can write it like this: 1 minus 9 by 10. So this is going to be equal to 0.01 centimeter. That is in the beginning I told you that the least count of a Vernier caliper is 0.01 centimeter. Generally, again, don't forget this term. Generally, that I am using again and again, because this is not that Vernier caliper can't be different. So Vernier calipers can be different as well. Okay, they can be what? They can be different as well. Okay, what if in 9 divisions of main scales we have 20 division of Vernier scale? Oh, sir, how it is possible? It is definitely possible. It is definitely possible. What is wrong in that? Are you getting my point? Okay, so everything is possible. Please understand that. Okay, so Vernier scale can have the least count even lesser than what we are having in the general Vernier caliper. But for the ease of manufacturing and for the general use, okay, for general use, so like See, this is something which is used practically in many industries, in many laboratories, workshop. So in workshop, you don't want to create this confusion, right? Okay, so this is a standard that mostly all the vernier calipers available in the market are having the least count of 0.01 centimeter, because the person who might be using it at the ground level may not be knowing all this calculation, all this concept. Okay, so for making him understand the measurement, this is kept like that. Okay, but it can be different. Okay, now let's do some questions. So we have come to understand what is the least count, but we still haven't seen that how to take the reading. I'll come to that, but before that, let us see some questions of finding the least count. Okay, so I'll write it for you. Just give me a moment. So it says in a vernier caliper, the main scale is marked in mm. Main scale is marked in mm. Okay, and 20 vernier scale divisions are equal to 16 main scale divisions. Okay, calculate the least count. Calculate the least count. So it is going to be 0.02 mm. Okay, option A. Option B is 0.05 mm. Option C is 0.1 mm, and option D is going to be 0.2 mm. So let's solve this question. I'm very sure we can do it. Please try doing it. Please solve this question. I'm quite sure we can do it. No problem at all. Please try to do that. Please try to do that. I'm quite sure we can do. So it says in a vernier caliper, the main scale is marked in mm, and 20 vernier scale divisions are equal to 16 main scale divisions. Okay. Okay, very well, sir. How to do it? So, sir, we know that the least count is equal to MSD. Okay, the least count is equal to MSD 1 minus M by N. Okay, or we can write like this: MSD minus VSD. Okay, we can go from the basic. So least count is MSD minus VSD. Okay, okay. Now see, if you don't remember anything, also see, it is written that 20 one-year scale divisions are equal to 16 main scale divisions. So it is going to be 16 by 20 of main scale division. So it is going to be the main scale division and 1 minus 16 by 20. 1 minus 16 by 20. So from here, we can put the least count. So 1 MSD is 1 mm, and this is going to be 1 minus 16 by 20. 16 by 20, so it is going to be equal to 0.2 mm. So when we calculate it, we are getting 0.2 mm. Okay, okay. So not necessarily, please understand this, what I'm trying to tell you, not necessarily all vernier calipers have the least count of 0.01. Okay, not necessarily all the vernier calipers have the least count of 0.01. Okay, now let's do one more. This is a neat question. Okay, let's try this one. I'm very sure we can do it. No problem at all. Please go for it, guys. Please go for it. Very, very simple question, guys. Please try this one. I'm very, very sure we can do it. No problem at all. So the live student can respond to me. The recording, the students who are watching the recording can pause the video and can answer me. Okay, so it says n main scale divisions are equal to n plus 1 Vernier scale division. If each division of main scale measure A, the least count will be. Okay, so we want to find the least count here. Sir, we know the least count is main scale division minus Vernier scale division, right? Least count is main scale division minus Vernier scale division. So can I write like this? So main scale division minus Vernier scale division. So Vernier scale division is, so what? So n MSD are equal to n plus 1 VSD. So 1 VSD is equal to n upon n plus 1 MSD, right? Okay. Okay. So it is going to become MSD, okay, 1 minus n upon n plus 1. Okay, and what is this equal to? What is this MSD equal to? So MSD is given to be, so main scale, each division of main scale measure, A. So we can put the value of A here. So this is going to be n plus 1 minus n. So it is going to be 1 upon n plus 1. Okay. So what is the least count? Least count is A upon n plus 1. A upon n plus 1. Right? Okay. No problem at all. So, sir, this is how we can find the least count of a Vernier scale. This is how we can find the least count of a Vernier scale. Now let's see that, sir, how can we take the reading from the Vernier scale? So, reading from Vernier scale. Now, please understand this. It is very, very simple. And in the same way, we can see the reading from the screw gauge also. So when we will be talking about the screw gauge also, that is also going to happen to be in the same way. So reading on Vernier scale, see, okay, reading. So I'll write it as, see, I'll just give you the formula and then I'll explain. Okay. So total reading, okay, total reading, that means the final reading of the Vernier scale. So total reading or the final reading of the Vernier scale is equal to reading on main scale. So I'll write MSR, okay, plus reading on Vernier scale. Okay. So MSR is main scale reading. Okay, so whatever is the reading of the main scale, okay, okay, and VSR is reading on the Vernier scale, main scale reading and Vernier scale reading, okay, MSR and VSR, okay. So when you add, so when you are taking the reading from the Vernier scale, you have to see what is the reading on the main scale, and you have to see what is the reading on the Vernier scale. And when you combine both of them, okay, when you are going to combine both of them, you are going to get the total reading. You are going to get the total reading. So what is this main scale reading? What is this MSR? How we are going to take this MSR? Now, please understand this. Please understand this. So we had this Vernier caliper. Okay, I'll just paste this photograph again. Okay, we had this Vernier caliper, and let's suppose we wanted to measure an object, some object. So we placed it here. When we placed it here, the jaws are somewhat like this. Okay, the jaws are somewhat like this. Now please observe. So please observe. So if you see here, just have a look at it here. Okay, okay. I'll just expand this one. I'll just give me a moment. I'll just magnify this. Okay, I'll just magnify this. Yeah. Okay. I have to do like this. Just one moment. Yeah. Just wanted to give you extreme clarity on this. Yeah. Just observe. Just observe. Okay. Just observe. Okay. Okay. So, sir, here the Vernier scale divisions don't look at this. So there are different ways of representing. This is not incorrect, but this is something. So you might be thinking, sir, here we can see that Vernier scale division is greater than the main scale division. Oh, don't do like this. Don't think like that. Okay. See, it is written 0.05 mm. Okay, 0.05 mm. So they have given you that each is 0.05 mm. So this is something you don't see that. Just try to see till what I am trying to show you. Okay. Now please observe here. So if I wanted to take the reading, so see 0, 1, 2, 2.1, 2.2, 2.3, 2.4. Okay, 2.4. Okay. Now you see that the zero of this Vernier scale, I hope you can observe this, the zero of the Vernier scale is somewhere after 2.4 on the main scale. See, 2, 2.1, 2.2, 2.3, 2.4. Afterwards, this 0 doesn't go to 2.5. Okay, it is slightly behind 2.5. It is to some extent behind 2.5. It is to some extent behind the 2.5. So when it is some extent behind the 2.5, that means the main scale reading in this case is 2.4. Main scale reading is 2.4. So what is the main scale reading, sir? What is the main scale reading? So main scale reading is it is the reading on main scale. It is the reading on main scale just before reading on just before 0 on Vernier scale. Okay. Okay, so when you do any measurement, you would see that there is a reading on the main scale which is just before the 0 on the Vernier scale, like this one I have shown you here. I'm trying to show you here. Okay. Okay, so here you see before the 0 on the Vernier scale, we have the 2.4 reading. Okay, so MSR is the reading of the main scale just before the reading on the 0 on the Vernier scale. So let me make it here. Just a moment. Huh? See, let's suppose this is the main scale. So we have 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Like this. Okay, and let's suppose we have the Vernier scale here. We have the Vernier scale here. So this is the zero of the Vernier scale, and then we have some readings: one, two, three. I'll just like this. Some reading. Just so I'll just, because I'm making it from my hand, so just like that. Okay, okay, like this. Okay, like this. Now, please understand this. Please understand this. Let's suppose this is zero. Obviously, this one. It is two. It is like this. This is the main scale, and it is calibrated in centimeter. The readings are given in centimeter. So now I want to, now please understand this. So I want to have the reading. So the total reading is going to be the main scale reading plus the Vernier scale reading, right? The total reading is going to be the main scale reading plus the Vernier scale reading. Okay. Okay. So what is going to be the total reading? So the total reading is going to be, see, what is the main scale reading? So main scale reading is the reading on the main scale just before the zero on the Vernier scale. So clearly, sir, just before zero on the Vernier scale, the reading is 1 centimeter. So MSR here is 1 centimeter. MSR clearly here is 1 centimeter. Now, what is the VSR? That is the question. What is the VSR? So see, VSR, that is Vernier scale reading, is the least count. Least count we already have learned to find into least count into coinciding division. Least count into what? Least count into coinciding division of coinciding division of 1 year scale. Of 1 year scale. So when you do it practically, you will get more corrected. But you see from here, if you see from the diagram I have made, from the figure I have made, so the main scale reading is clearly 1, because 1 is just before 0. Now, when you see the divisions of the 1 year scale, okay, now you have to count it. So this is 1, 2, 3, 4, 5. Okay, now you see coinciding division. What do you mean by coinciding division? So if you see, observe this and this. So this is not in line. This and this, they're not in line. This and this, they're not in line. So this and this, not in line. This and this, they're not in line. But if you see this one, okay, this one, so this one, this. So you see that this is coinciding. This is coinciding. So you have to count it. You have to count it. So 1, 2, 3, 4, 5, 6. Okay. So the sixth division on the Vernier scale is coinciding exactly to some division of the main scale. To some division of the main scale. Okay. So you have to see this coinciding division, and then you have to multiply it with the least count. Okay. Then this way you get the Vernier scale reading. So if the least count is 0.01, if the least count is 0.01, okay, so the coinciding division is 6, so it is going to be 0.06. It is going to be 0.06. So what is the total reading? Total reading is going to be, MSR is 1 centimeter and this is 0.06 centimeter. So this is going to be 1.06 centimeter. Okay, 1.06 centimeter. Okay. Okay, now you see that you have managed to measure up to 2 decimal place using this. And if you observe in this one, okay, let's try to make the measurement. Now MSR is 2.4 clearly. Now see the coinciding division. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is not actually the right way of representing now, because this is the calibration in this BSC is more than the MSD. So it is the second case. But let's suppose I'll just make a few more. Okay, I'll just make a few more. So if it coincides here, like this is not coinciding, this is not coinciding, but this coincides. So it will become 1, 2, 3, 4, 5. So the fifth division coincides. So the Vernier scale reading would be whatever is the least count into the fifth division. So the division which coincides, okay, the division which coincides with the main scale, any of the main scale division, okay, it is not like the fifth is to coincide with the fifth only. Any, just you have to see this, that which division of, which count of division of the Vernier scale is coinciding, that is coming exactly in line to the main scale, sum of any of the main scale division. Okay. Okay, so what is the formula then? What is the formula then? So I'll just clarify it here. So we have the total reading. So what is the reading of the Vernier caliper? So it is going to be the main scale reading plus Vernier scale reading. So main scale reading is going to be the reading on main scale, the reading on main scale, the reading on main scale just before zero of Vernier scale. Okay. And what is going to be this VSR, Vernier scale reading? So it is going to be the reading on, or it is going to be not the reading on, it is going to be the least count into the coinciding division. Okay, if it is 6 you can write 6 here, if it is 5 you can write 5 here. Okay, so it is going to be the least count into coinciding division of the Vernier scale. Okay. Okay, and this is only valid, okay, so like in the picked you see, so valid only when there is no zero error. What is zero error, sir? I'll explain. No worries. There is no zero error. So see, I'll just give you a glimpse of what is zero error right now. And also, when VSD, that is vertical Vernier scale division, is less than the main scale division. If Vernier scale division is not less than the main scale division, the thing is going to get reversed. Okay. Okay, so what is the zero error? So sometimes what happens when you use the Vernier caliper quite heavily. So initially in the close position, when Vernier caliper is in the close position, the zero of the Vernier scale and zero of the main scale shall exactly coincide. They shall exactly coincide. Understood? They shall exactly coincide. Okay? Okay. Now let's solve one question. I'll just write it for you. Please read the question carefully. Okay. Please read the question carefully. So this is your NEET previous year question. Let's try to do it. I'm very, very sure we can do it. Please go for it. Let's try to do it. So the live student can tell me the answer to this question. Please attempt. I'm waiting for the live student to solve this question. Please try to solve this question. I'm very, very sure we can do it. Very interesting. Very, very simple question though. Please try to do it. Please try to do it. I'm very sure we can do it. No problem at all. Very easy question. Please go for it. So how we can do it? So it says in a Vernier caliper, 10 Vernier scale divisions are equal to 9 main scale divisions. And 1 centimeter on the main scale is divided into 10 parts. Okay. So there are 10 divisions on the main scale. While measuring the length of the line, so 1 centimeter of the main scale is divided into the 10 parts. So that means each of it represent. No, please understand. Let's understand this language first. So in a Vernier caliper, 10 VSD is equal to 9 MSD. Okay, that is okay. 1 centimeter on the main scale is divided into 10 parts. So 1 centimeter is divided into 10 parts, into 10 divisions. Okay. Okay, so that means 10 divisions of main scale. See, this is how they twist the language. So one main scale division is obviously equal to 1 by 10 centimeters. So that is 0.1 centimeter. Okay, but you can relate that. See, here in this question, it is given 1 centimeter is divided into 10 divisions. Okay, but this could also be the case. This could also be the case that 1 centimeter may divided into 100 divisions, 20 divisions, 50 divisions. So accordingly, the things are going to get changed. Remember that. So main scale division is equal to 0.1 centimeter. Okay. Okay. Now, we need the least count also. So, while measuring the length of the line, the zero of Vernier scale is just ahead of 1.8 centimeter mark. And fourth division of the Vernier scale coincide with the main scale division. The length of the line is. So, main scale reading is given. Vernier scale reading we have to obtain, and for that we will be requiring the least count. Okay. So least count is the main scale division minus Vernier scale division. So main scale division is 0.1, Vernier scale division is 9 by 10 of main scale division, that is 0.1. Okay. Okay, it is given that 9, 10 Vernier scale division is equal to 9 main scale division. So zero point 0.1 main scale division is 0.1, Vernier scale division is 9 by 10 of 0.1. So it is going to be 0.01 centimeter. So this is the general Vernier caliper we are talking about in this question. The general Vernier caliper again is the one which is available in the market, in your schools, in industries, in laboratories. So this is the general Vernier caliper we have with us, right? Okay. Okay, sir, we got the least count. Now let's talk about the reading. So what is the length of the line? What is going to be the length of the line? So obviously, sir, the length of the line is going to be the total reading of the Vernier scale. So what is going to be the total reading, sir? Total reading is going to be equal to, sir, main scale reading plus Vernier scale reading. Okay, that means what is the main scale reading? So see what is written. So Vernier scale is just ahead of 1.8 centimeter mark. Okay, so that is 1.8. So what is the reading before the zero of Vernier scale? It is 1.8. And what is the VSR? So sir, it is least count into the coinciding division. So coinciding division is 4. So 0.01 into 4. So we are getting 1.8 plus 0.04, right? Centimeter. So we are getting 1.84 centimeters. Okay, so what is the nearest answer? It is B option, that is 1.840 centimeter. 1.840 centimeter. I hope it is clear to everyone. Right? Okay. Okay. Now, 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 please understand this. Please understand this. Let's move to the next question. And see, there are, see, MSD, VSD, I hope that is clear to you. Division thing is clear to you. Taking reading is also clear to you. So I'm going to give you one question, which is perhaps I found the one of the very tricky question. It is from the JEE examination, and I found it quite good. Okay, so if you are able to solve this question, okay, I believe that you will be able to solve any question asked from this domain. Okay. Okay. And remember, this is changed to unit number 20 in the new syllabus. So it is very likely that they can have a question from this Vernier caliper or screw gauge. So I'll just give you one question and I'll give you time to solve that. Okay. So the dia of a cylinder, the dia of a cylinder is measured using Vernier caliper. Okay. Okay, with non-zero error. With non-zero error. Okay. Non-zero error means there is no zero error. So what is zero error? I'll tell you. Don't worry. After this question, I'll tell you. Okay. Now it is found. It is found that zero of Vernier scale lies between 5.10 centimeter and 5.15 centimeter of the main scale. See, please be very careful while you solve this question. Okay. The Vernier scale has 50 divisions. The Vernier scale has 50 divisions equivalent to 2.45 centimeter. Okay. The 24th division, the 24th division of Vernier scale, the 24th division of the Vernier scale exactly coincide with one of the main scale division. Okay. The dia of cylinder is the dia of cylinder is, okay, what is going to be the dia of cylinder? So this is 5.112 centimeter. Second option is 5.124 centimeter. Okay. C option is 5.136 centimeter. And the last option is 5.148 centimeter. Now you need to give the answer to this. Please go for it. Please think carefully before you answer. Let's try doing it. I'm quite sure that you can do it. Any answers by the live student? I can see some of you are watching live. Please do it. कोशिश करिए सॉल्व करने का. Please try to do it. Very interesting question. So if you are attempting and haven't solved yet, okay, or you are attempting, please pause the video, solve it first before I do. Okay, I want you guys to solve this question before I do. So see, how can we do this question? So it says the dia of a cylinder is measured using Vernier caliper with non-zero error. Okay, with non-zero error, it is found to be, it is found that the zero of Vernier scale lies between 5.10 and 5.15 second. Okay, okay, okay. Lies between 5.10 centimeter to 5.15 centimeter of the main scale. So we have to process this information. Okay, we need to process this information. So how? I'll tell you. Don't worry. The Vernier scale have 50 division equivalent to 2.45 centimeter. The 24th division of Vernier scale exactly coincide with one of the main scale division. So obviously to solve this, we require what we require, sir. So we are requiring. So we require what, sir? We require. So we have total reading. So we want to have total reading or Vernier scale reading. So it is equal to the main scale reading. It is equal to the main scale reading plus Vernier scale reading. Main scale reading plus Vernier scale reading. Now, main scale reading is what? So it is found that it lies between 5.10 and 5.15. So 5.0 lies between 5.10 and 5.15. So let's try to visualize this. So see, there will be, so let's suppose this is your main scale. Okay. This is your main scale and this is somewhere your Vernier scale. This is the zero of Vernier scale. Okay, so it lies between, see, it lies between 5.10. So that means this has to be 5.1 and this has to be 5.10 and it has to be 5.15. Now see, if you process this information, see, lot of things are going to get clear to you. So what is the main scale reading? So main scale reading is the reading just before the zero on the Vernier scale. So just before zero on the Vernier scale, this reading is 5.10. But for Vernier scale reading, we require least count, okay, into coinciding division. Into coinciding division. So coinciding division is clearly this is 24 division of 24 division of Vernier scale. So 24, this is going to be 24. But sir, what is the least count? Now please understand this. So least count is main scale division minus Vernier scale division. Okay. Now what is this Vernier scale division? So please understand this. So Vernier scale has 50 division equivalent to 2.45 centimeter. So can you say, see, obviously when 50 divisions are giving you 2.45 centimeter, that means each division is going to give you 2.45 by 50 centimeters, right? This is fine, it's same. Now the question is, sir, what is the main scale division? Is it 0.1? Is it 0.1? Now please understand this. Now see, this is how the information is given in the question. It is sometimes hidden in the question, I may say. So see, it says that the zero Vernier scale lie between 5.10 and 5.15. So this is 10, this is 15. Now please understand this. So what is this going to be? This is the main scale division, no? This is the main scale division. So this is going to be 0.05 now. See, 5.1 and 5.15. That means the next reading would be 5.20. Another reading would be 5.25. So each division is of 0.05 centimeter. Okay. Otherwise, it would be 5.1 to 5.2. It would have lied between 5.1 and 5.2. When it says that that 0 is lying between 5.10 and 5.15, that means that each division is of 0.05 centimeter, right? Okay, so from here we can try to calculate. So when we are calculating it, we are getting 0.001 centimeter. So here the least count is 0.001 centimeter. So from this very vernier caliper can we measure up to 3 decimal places, because the least count is 0.001. That is why from starting I kept saying that generally vernier caliper is used for measurement of a measurement till 2 decimal places. It has least count of 0.01 because it can have the least count even lesser than 0.01. It can measure the quantity, the length to accuracy up to 3 decimal places at times. Okay, okay. Okay, so the least count is 0.001. Now we can put it here. We can put it here in the total reading or the vernier caliper reading or vernier reading, whatever you say. So it is going to be 5.10 plus least count is 0.001 into 24 into 24. So from here we are going to get 5.124 centimeter. Okay, so here you can see that we can accurately measure up to 3 decimal places, that is 5.124 centimeter. I hope it is fine to everyone, right? So guys, these are the questions of the vernier scale, how to get the least count, how to get the reading. Okay, normally this is getting asked in the examination. Now one last thing I'm going to tell you today, and with that I'll be completing in one lecture the whole vernier scale. Okay, vernier caliper is completed. We can solve n number of questions from here. Okay, I have covered the vernier caliper from very scratch. Okay, and I hope that if you have watched this session carefully, you would be able to know each and every concept of this vernier caliper, and definitely you will be able to solve question. Once you know the concept, you will be able to solve the question. Now please understand, this very simple concept is there. Zero error. Zero error. This will also be there in the screw gauge that we are going to see in the next session. So zero error, what is zero error? So there is two types of zero error. One is positive zero error. One is positive zero error. Okay, and another is negative zero error. Okay, okay. They both have the same process to solve. So zero error is classified into two. One is positive zero, another is negative zero error. So see, when the zero error will come. So see, before using, see sometimes we use vernier caliper a lot. It is very frequently used in some laboratories and some workshop context. So what happens due to the frequent use? Okay, so in closed position of a vernier caliper, the zero of the main scale and zero of the vernier scale shall exactly coincide. They shall be exactly coaxial, coincide with each other. But sometimes due to like the vernier caliper I am having, if you could see it. So when I am closing it, it is having some zero error and it is having some positive zero error. I can see here. I'll have to tell the lab instructor today that we are having the zero error in this vernier caliper. Okay, okay. So see what is zero error. So see, a good vernier caliper, an errorless vernier caliper will have in close position the zero of the main scale would be exactly coinciding with the zero of the vernier scale. But when it has zero error, it is not going to happen this way. And in this, what happens? So let's suppose this is the main scale 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's suppose this is your mean scale. Okay. And we have the Vernier scale. Now in the Vernier scale, this is the zero of the Vernier scale. These are the divisions on the Vernier scale. Now if you see that zero is ahead of, like it is, if I say this is positive x-axis, this is negative x-axis. So you see that this is when the zero of the Vernier scale is in the positive side of the zero of the main scale. So for zero error to happen, for zero error to happen, for zero error to happen, there is one necessity, that the zero of the main scale and the zero of the Vernier scales are not coinciding. So in the case of positive zero error, in the case of this positive zero error, your in the case of positive zero error, your Vernier scale zero will be somewhat ahead to the zero of the main scale. And otherwise, in negative zero error, what happens in the negative zero error? What happens? So these are the calibrations on the main scale. Let's make some randomly. Now in the main scale, what happens? So this is the zero of the main scale, and the zero of the Vernier scale is behind, that is in the negative of the zero of the main scale. So zero of the Vernier scale, if it is ahead of the zero of the main scale, this is what we call as the positive zero error. If the zero of the Vernier scale is behind the zero of the main scale, it is the negative zero error. And how we are going to get the zero error? It is very simple. We just have to use one formula. See, so whether it is positive zero error, okay, it is going to be least count into. So see, first of all, see, these zero errors are to be calculated before measurement. It is not that it is to be calculated after measurement. Okay. So when your Vernier caliper is in ideal condition and you saw that the zeros are not matching, you at that point of time see that which division is coinciding. Like for example, this is the Vernier caliper. I can see that zero is not matching. Now I have to check that which division is exactly coinciding. So which division is exactly coinciding? So it is the seventh division which is exactly coinciding. Okay, it is the seventh division I can judge from this Vernier caliper, that the seventh division is exactly coinciding. But before measurement you have to do. Okay, okay. Now what is the negative zero error? What is the negative zero error? So it is going to be minus of. Why minus of? Because it is behind now. And the formula remains same. Again, least count into coinciding division of Vernier scale. Coinciding division of Vernier scale. Okay. Okay. So just think in a way. So let's suppose that our Vernier caliper has positive zero error. It has a positive zero error. So positive zero error, and when you use this to measure some dimension, so obviously that dimension, that measurement that you are getting will be more than what is actual measurement, because it has some positive zero error. It is already shifted from its zero position. So when you take the reading, it is obviously going to be more than the actual reading. Okay. And in the negative zero error, what has happened? So you are going to get the final reading to be less than, okay, to be less than what is the actual reading. So when your Vernier caliper is having positive zero error, you need to Subtract, yes, you need to subtract because you are getting more than the actual. And when you have negative zero error, you need to add. You need to add. So you don't have to use that much brain. See, this is the formula. One thing to remember, zero error is to be measured, zero error is to be calculated, zero error is to be calculated before measurement. Just remember that. Calculated before measurement. Okay, this is something. So it is to be calculated before measurement. Secondly, it is always to be subtracted. See what is the true reading, or we can say what is the actual reading or correct reading. Correct reading. So see, you have to go by the same way to solve, and you get the total reading. Okay, main scale reading plus Vernier scale reading. So you get the total reading. From that total reading, you subtract the zero error. You subtract the zero error. Now, when from the total reading you subtract the zero error, it is if it is positive zero error. If it is positive zero error, so the final correct reading would be somewhat less than the measured reading, right? And see, when you are putting negative zero error here, so negative, you will put something into negative, negative will become positive, and you are going to get the correct answer. Okay, right? So all you have to do is using this thing, find the zero error, and then use this formula to get the correct reading. Okay, so you can remember total reading minus zero error. Positive zero error, as the name suggests, it is having some positive value. Negative zero error, as the name suggests, it is going to have some negative value. Okay, okay. Now, guys, in this session, we have completed the Vernier caliper. So it was a quite a long session, okay, because this is somewhat a big topic, obviously. So this session we have completed Vernier caliper completely. I tried to give you like very practical context of Vernier caliper. We have solved some questions of Vernier caliper as well. Now the question, the intensity. See, I have chosen the questions which will give you some. So direct question everybody can do now. Some MSD minus VSD. Normally, many people you have seen, so we are doing this question MSD minus VSD, but we do not know the in depth of this, and in that cases you can make mistake if a question goes is slightly tricky. Okay, it's slightly tricky. So under that circumstances, I think we have seen this very practically, very experimentally as the NEET want us to do. Okay, and I hope you are going to solve many problems out of this particular topic. Okay, okay. So guys, we'll keep it to this point in this session, and in the next session we'll be exploring the screw gauge in the same way we have learned of the Vernier caliper. Okay, so after you understood this Vernier caliper, screw gauge is not going to be that difficult for you, I assume. Okay, because the zero error is nearly the same for the screw gauge also. Okay, this is like that, and you will going to feel very comfortable in that. So there is nothing to worry about. Okay, so guys, I'll keep it to this point in this session. I hope you enjoyed this session, and ultimately I'm requesting you to please subscribe the channel NEET Success Simplified. If you are enjoying these sessions, if you find it informative, if you find it that this is helping in your preparation, because we try very hard to make you NEET ready, make you doctor. Okay, we are here to fulfill your dreams. So please subscribe, and please do join in the live session. Okay, more, and when you subscribe it, you will get the notification of all upcoming chapters on this channel. We have biology going in full thrust, physics going on full thrust, and we are trying to finish your syllabus as soon as we can. Okay, okay. So guys, let's hope for the best, and I'm going to see you in the next session. So with this, thank you very much. Have a good day, and we'll see you in the next session.